Sketch Bode plot for the following transfer function. Sketch Bode plot for the following transfer function and determine the system gain k for the gain crossover frequency to be 5 radians per second. So here for omega gc equal to 5 radians per second, you have to determine the system gain k value. So the given transfer function is g of s, that is open loop transfer function is given, that is g of s equal to k into s square by 1 plus 0.2s into 1 plus 0.02s. So this given open loop transfer function, first of all it must be converted into sinusoidal transfer function, that is g of s must be replaced by g of j omega. So s must be replaced by j omega. So in the given open loop transfer function, replace s by j omega, you will get g of j omega equal to k into j omega to the power of 2 by 1 plus 0.2 j omega into 1 plus 0.02 j omega. Okay, so 1 plus in the denominator 1 plus 0.2 j omega into 1 plus 0.02 j omega. Now this is our sinusoidal transfer function. Now let us check how many basic factors are there in the given open loop transfer function. So if you see in the numerator, there is one factor, that is derivative factor, that is j omega to the power of 2. Of course there is a gain constant k, whose value we have to determine, and in the denominator one first order factor is there. Okay, another first order factor is also there. So total including k, total we can say constant gain k, one factor, other one is derivative factor, and other one is first order denominator factor, and another one is first order denominator factor. Okay, so total actually 4 factors are there, and among we have to determine k value at omega equal to 5 radians per second, means at gain crossover frequency. When omega is omega gc, we have to determine the k value. So now let us assume k equal to 1. Okay, if we assume k equal to 1, only 3 factors will be left over. One is derivative factor, other one is first order factor in the denominator, other one is first order factor in the denominator. So total 3 factors are there now, assuming k equal to 1. Now let us plot the magnitude plot. Okay, so now to plot the magnitude plot, let us check our g of j omega. In this g of j omega, there are 2 factors which will have corner frequencies. So we have to search for the corner frequencies. So which factors will have corner frequencies? So we know first order denominator factors will have corner frequencies, derivative factor will not have corner frequency. So consider these 2 factors. So what is it? It is in the form of 1 plus j omega t, and this is also in the form of 1 plus j omega t. What is t value in this factor? 0.2. What is t value in this factor? 0.02. Okay, so what is corner frequency formula? Omega c equal to 1 by t. So omega c1 equal to 1 by 0.2, you will get 5 radians per second, and omega c2 equal to 1 by 0.02, you will get 50 radians per second. So we have got 2 corner frequencies now. Okay, so we have got 2 corner frequencies, omega c1 equal to 5 radians per second, and the corner frequency omega c2 equal to 50 radians per second. Now let us draw a table. Consider it as table 1. So first of all, in the first column of the table, write down the terms that are available in the given open loop transfer function. Here we have assumed k equal to 1, so no need to write k value. So write down the other terms, derivative factor, first order factor in the denominator and first order factor in the denominator. Write down those terms in the first column of the table. In the second column, let us write down the corner frequencies for each term. Okay. So corner frequency for derivative factor will not be there, so nothing, there is no need to write here anything. What is the corner frequency for this factor? It is omega c1, that is 5 radians per second. Corner frequency for the next term, that is first order denominator factor, omega c2 is 50 radians per second. Okay. So this is our second column. Now let us go to the third column. In the third column, we must write down the slopes. Okay. So slope for the derivative factor is 20 plus 20 into n, where n value is to the power of whatever value is there, that is n value. So plus 20 into 2, you will get plus 40. So slope for the first order factor in the denominator is minus 20. Write down minus 20. Slope for the first order factor in the denominator, that is also minus 20. Write down minus 20. So the slopes for the terms that are available, that are given in the open loop transfer function. So slopes are plus 40, minus 20 and minus 20. Now the fourth column is change in slope. The fourth column is change in slope. So for the first term, there will not be any change in slope. Okay. For the first term, there will not be any change in slope. So write down the slope of first term in the column of change in slope of second term. So 40, whatever 40 that you have got here slope value, they just write down in the second column, second row, and you just add it with the slope value of the second term. Slope value of second term is what? Minus 40. Slope of first term is plus 40. Sorry, slope of first term is plus 40. Slope of second term is minus 20. So plus 40 minus 20, you will get 20. Okay, plus 40 minus 20, you will get plus 20. Okay, now write down this plus 20 in the second row, the next row, not second row, sorry, it is the third row. In the third row, and add the slope of that particular term of that row to this slope value. Okay, so this slope, whatever you have got in the for the second term, write down as it is in the third row and add it with the slope of the third term. If you add 20 minus 20, you will get 0. So this is the change in the slope. Okay, so change in the slope for first term there will be nothing for change in the slope for the first term. So for the second term, this is our second term. For the second term, what we have to do is to determine the change in the slope. What you have to do is write down the slope of the first term, add it with the slope of the second term. If you add it, 40 minus 20, you will get 20. Write down whatever change in the slope of the second term is there in the third row. Okay, and add it with the slope of the third term. If you add it, you will get 0 here. Okay, so now this is our table 1. Now we have two corner frequencies. What is it? Omega c1 is 5. Other corner frequency omega c2 is 50. Now let us consider two more frequencies, one low frequency, one high frequency. Okay, one low frequency and one high frequency. So low frequency, let us assume it is omega L. High frequency, let us assume it is omega H. Low frequency should be less than the lowest corner frequency. Among these two corner frequency, which is the lowest? 5 is the lowest. So omega L should be less than 5, and higher frequency should be greater than the largest corner frequency. The largest corner frequency is 50. So omega H should be greater than omega c2. Means omega H should be greater than 50. Omega L should be less than 5 and omega H should be greater than 50. So some value below 5 I have assumed omega L. Okay, I have assumed omega L equal to 0.5 radians. 0.5 is less than 5. So we can assume any value below 5. And omega H, omega C2 is 50. So omega H I have assumed 100. Okay, any value above 50. You can assume 60, 70, 80, your wish. Any value. So assumptions are always our wishes. So how many frequencies do we have now? Omega L. Okay. Omega C1, omega C2 and omega H. Okay, total 4 frequencies we have now. Omega L value is 0.5, omega C1 is 5, omega C2 is 50, omega H is 100. Okay, so these are all our frequencies. Now, for each frequency, let us determine the gain. That is A. A is our gain in decibels. Okay, so what is A in decibels? It is the magnitude of G of j omega in decibels. A is magnitude of G of j omega in decibels. So, let us calculate A value for omega L, omega C1, omega C2 and omega H. Okay. So, now when omega equal to omega L, so what is our omega L value? 0.5, isn't it? Just now we have assumed omega L value. So, omega equal to omega L, that is 0.5. Formula for A is 20 log of magnitude of G of j omega. So, what is G of j omega? The first term, derivative factor. What is the first term derivative factor value? Okay, j omega square is our first term. So, write down, instead of G of j omega, write down the first term, that is j omega square. Okay, and simplify it. If you simplify, you will get A is equal to minus 12 decibels. Okay. Now, let us consider first corner frequency, omega equal to omega C1. For the first corner frequency, formula is same. A is equal to 20 log of magnitude of G of j omega. Instead of G of j omega, write down the first factor, that is derivative factor, that is j omega square, and simplify it. You will get A is equal to 28 decibels. Okay. So, we have got two values now, A equal to minus 12 decibels. For omega equal to omega L, for omega equal to omega C1, we have got A equal to 28 decibels. Now, let us determine A for the remaining two also. After determining A value for first corner frequency, the formula for A will change. The formula for A is slope from omega C1 to omega C2. What is the slope from omega C1 to omega C2? For that, okay, for that we have to go to the table. We will go to the table later on. So, formula, let us see the formula first of all. A is equal to slope from omega C1 to omega C2 into log of omega C2 by omega C1 plus A into A at omega equal to omega C1. Okay. A at omega equal to omega C1. So, first of all, let us see what is the slope from omega C1 to omega C2. Let us go to this table. So, this is our omega C1 corner frequency, this is omega C2 corner frequency. What is the slope from omega C1 to omega C2? What is the slope? 20. Okay, 20 has been, it has been sent from this omega C1 term to omega C2 term. So, 20 is our slope. So, here write down 20. So, 20 is the slope from omega C1 to omega C2 into what is log of omega C2? Omega C2 value is 50 and omega C1 value is 5. So, log of 50 by 5 plus what is A at omega equal to omega C1? At omega equal to omega C1, what is A value? A value is 28 decibels. So, write down 28. Okay, just solve it. You will get A equal to 48 decibels. Okay, A is equal to 48 decibels you will get. Now, consider omega equal to omega H. Formula is same, slope from omega C2 to omega H into log omega H by omega C2 plus A at omega equal to omega C2. Okay. What is A at omega equal to omega C2? At omega equal to omega C2, what is A value? What did you get? 48. So this is our 48. Next, what is log omega h? Omega h value is 100. Omega C2 value is 50. So log 100 by 50. Now let us see slope from omega C2 to omega h. Let us go to the table. This is our table. This is our omega C2 term, isn't it? This is our omega C2 term, that is 50 here. So what is this change in slope here? 0. So if you have to, if there is any other omega above omega C2, that is omega h, so what will be sent to omega h? 0 will be sent to omega h. Okay, so what is the slope from omega C2 to omega h? It is 0. Okay, omega C2 to omega h, the slope is 0. So you just substitute all the values and simplify it. Okay, you just substitute all the values and simplify it. A is equal to what? 48 decibels that you will get. Okay, so we have got 4 A values for 4 omega values. So what are all omega values? Omega L, omega C1, omega C2 and omega H. We have got 4 A values. Let us consider 4 points A, B, C, D. And let us take a similar graph sheet and consider 1 unit equal to 10 decibels on y-axis. So let us go to the graph. This is a similar graph sheet. And on y-axis, A in decibels, 1 unit equal to 10 decibels. So our highest value was 48 decibels. So 50, 40, 30, 20, 10, 0, minus 10, minus 20, minus 30, minus 40. This is the y-axis scale. Okay, on x-axis, I have considered 0.1. This as 0.1. If this is 0.1, then 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. If this is 1, then 2, 3, 4, 5, 6, 7, 8, 9, 10. If this is 10, then 20, 30, 40, 50, 60, 70, 80, 90, 100. Okay. So omega value, omega h, if you remember, that is 100. So above 100, there is no need to take scale. So this is it. Now plot the graph for different omega values and for different A values. Plot the graph. This is what you will get. So what is this plot? This plot is for k equal to 1. This plot is for k is equal to 1. We have assumed k equal to 1, but they have asked us to determine the k value. We didn't determine the k value. We have simply assumed k equal to 1 and we have plotted the magnitude plot here. So this is just an approximate plot. This is not the exact plot. Why? Because k value, we have just assumed the k value. Now let us plot the phase plot. Okay, now to plot the phase plot, let us determine the phase angle. Phase angle is, it is the angle of g of j omega. So g of j omega has 3 factors. In the numerator it has j omega to the power of 2. Okay, so derivative factor phase angle is 90 into to the power of 2 n value into n, that is 2. So 90 into 2 minus, in the denominator there is one factor, first order factor. So 1 by j omega t, t value is 0.2. So tan inverse of minus tan inverse of 0.2 omega. One more first order derivative factor is there, therefore minus tan inverse of 0.02 omega. Okay, just solve it. You will get 5. These are 5 equal to 180 minus tan inverse of 0.2 omega minus tan inverse of 0.02 omega. Okay, now let us determine phi for different omega values. Okay, for different omega values we can assume omega values. Okay, so for different omega values let us determine phi. So for that let us draw a table. So this is our table number 2 for phase plot. So while assuming omega values in column 1 is omega. So while assuming omega values, make sure corner frequencies are also included. Our corner frequencies were 5 and 50. So I have included 5 and 50, and some values in between and below and above lowest corner frequency and highest corner frequency. I have assumed some omega values. So omega is 5, so I have assumed 0.5 and 1 below 5, and in between 5 and 50 I have assumed some 10 value. Above 50 I have assumed some, of course omega h was 100, so I have assumed 100 also. Okay, so our wish, you can assume any values. Okay, so you can assume any omega values. You assume some omega value, substitute all these omega values in this formula. Okay, substitute all omega values in this formula. Okay, substitute all omega values in this and determine phi, value. So if you solve it, if you determine phi value, so I have considered these two terms also here in the tabular column. So simply you can consider only 3 columns here. I have considered 5 columns. Okay, so for 0.5 omega equal to 0.5, what is my phi? 174. For omega equal to 1, 168. For omega equal to 5, it is 130. For omega equal to 10, it is 106. For omega equal to 50, it is 50. For omega equal to 100, phi value is 30. So we have got approximately 6 points. So consider some points on the phase plot, E, F, G, H, I, J. These are our points. Okay, and consider 1 unit equal to 20 degrees on y axis. Consider 1 unit equal to 20 degrees on y axis. Okay, now let us go to the plot. This is the y axis, phi in degrees. Okay, consider so based on whatever values that you have got, 1 unit equal to 20 degrees I have assumed here. So 20, 40, 60, 80, 100, 120, 140, 160, 180. So this is my scale. So this is my plot, phase plot. Okay, this is my phase plot. This is my magnitude plot for k equal to 1. Now let us determine k value. Now let us calculate the k value. Okay, so in the question itself they are given omega g is equal to 5 radians. Okay, we have to determine k at omega equal to 5 radians. So in order to determine k value at omega equal to 5 radians, let us first of all determine what is a value at 5 radians. What is a at 5 radians? Let us go to the graph. So this is omega gc 5 radians. Okay, omega gc. So at 5, from 5 draw a vertical line towards the magnitude plot. Okay, not towards phase plot. Of course it may intersect the phase plot, don't worry about it. Draw a straight line with the help of scale. Okay, you take the help of scale, draw a straight line, vertical line from omega gc, that is 5 radians, to it will meet the magnitude plot at some point. From that point now draw a horizontal line towards y axis. Okay, so it is meeting at 28 decibels. A value is what? A value is 28 at omega gc. A value is 28 at omega gc. Okay, so a value is 28 decibels. So from where did you get the a value? From the graph. So from the graph you have got a value is 28 decibels. But we know that at gain crossover frequency, okay, at gain crossover frequency the gain should be always 0 decibels. Means A should be equal to 0 dB. At what? At omega equal to omega GC. At omega equal to omega GC, A should be equal to 0 decibels, but you are getting A equal to 28 decibels. Now how to make A as 0? Already it is 28. How to make it 0? Simply add A value with minus 28. Simply add A with minus 28, so A will become 0 decibels. So in the magnitude plot you can see there are 4 points, A, B, C and D. To each and every point add minus 28. So to each and every point, for example, this is B point, that is 28. 28 minus 28, what do you get? 0. So here this is my 0 point. Okay. Similarly, this is minus 12. This is minus 12. Point A is at minus 12. So minus 12 minus 28. What do you get? Minus 40. So from minus 40, draw a straight line to this exact location. Okay. This is my point. Similarly, C and D are at plus 48. Minus 28, 48 minus 28. What do you get? 20 you will get. So at 20, from 20, no need to draw a line. So these two are my points. Okay. So simply I will show you the graph. This is it. So just check the difference. A has shifted down by minus 28 and now this point is A dash. B has shifted down to B dash. The length of this means the length between this point and this point is minus 28. So C has shifted to C dash, D has shifted to D dash. Okay. Now join A dash, B dash, C dash and D dash. You will get a new plot. We don't know K value now. We still have to determine the K value. We still have to determine K value. Now let us determine the K value. So to determine K value, the formula is 20 log K should be equal to 20 log K should be equal to minus 28. Why minus 28? Why? Because you have shifted the plot from magnitude plot. You can see in this magnitude plot. Okay. So omega GC can be obtained at 0. At omega GC, A should be always 0. Okay. That's why you have shifted your whole magnitude plot by minus 28. That's why 20 log K should be equal to minus 28 decibels. Okay. So 20 log K is equal to minus 28 decibels. So you just simplify it, you will get K equal to 0.0398. Okay. So for now we have got 2 magnitude plots and 1 phase plot. So among these 2 magnitude plots, this is our exact magnitude plot. K value we have got at omega equal to omega GC. Okay. So K value is 0.0398. Okay. So another magnitude plot for K equal to 1 and 1 phase plot.